My name is Caroline Gakii, currently a student doing masters in data science, and we trained a model being guided by Dr. Maitevia. This model is supposed to classify the cancer images and predict whether they are cancerous or non-cancerous. And before we settled for this model, I trained a couple of models, and I picked the one that yielded high performance. And one of the models that we trained before picking this model was EfficientNet v2. I also trained another one, the ImageNet, and we finally settled for ResNet 50 Net v2, which was the best in accuracy, and it could predict the cancer images well. So I trained it on the Breakis data set, which we picked publicly because it had many images, and majorly the malignant images, which are cancerous, were more than the benign images, which are non-cancerous. And this data set was not well organized, so I had to reorganize because it was given on different magnification factors. So I had to reorganize the data set and have the malignant images put in a single folder, and the benign images, which are non-cancerous, in a single folder for easy training. And we had about 5,400 and something images for the malignant images, and the benign we had 2,400. Like you can see, there is a bit of imbalance, but either way, the model performed very well. There is ResNet 50 v2. So after reorganizing the images, I started training on different phases. The first phase, there is something that is called the epochs, the number of times you put the model through the data set. And that is, I started with 5 epochs, went to 10 epochs, went to 16 epochs, and ended with 20 epochs. I had to do all this because sometimes there is something that we call overfitting, where you overtrain the model, and it might become too accurate, and it's supposed to be balanced. So after I trained on different epochs, I picked 16 epochs, which was a perfect fit. It yielded a 98%. For a model to predict well on the new samples that are being put through the model, it needs to have a good accuracy. And this one, the 16 epochs, was the best choice. So after finally settling for 16 epochs, we tried our model on new images or new samples collected from the clinic with the team. So in case you are wondering what is epochs, an epoch is how the model go through the data set that we have. In this case, we have a Breakis, and the model has to go through the images through the epochs. Now, if I settled with the 16 epochs, so the model went through the Breakis data set 16 times to generalize and learn the patterns of on the cancer images. That is how, remember that if our model overfits, it tends to memorize instead of generalizing. The goal is to generalize the images that we are training with, so that when it is put on the new images, it is able to predict without necessarily remembering or memorizing. So that is one thing that we consider before picking the right model. And so, like I was saying, we picked, or we got samples from the clinic, and we tested our model, and most of the images were predicted correctly. If it is a cancerous tissue, it was predicted as malignant, and if the image was or the tissue was benign, benign means it is non-cancerous, it was predicted as benign. That is very important when we are testing the model, that it predicts the images correctly. And one thing that we noticed and we are still working on so that we can rectify is that our break-keys data set was not balanced, where we had more malignant images and less benign images. So we are working on that so that we can balance our break-keys data set, or the data set that we are using to train our model on, so that it can be accurate and we avoid red flags where maybe a benign image is flagged as malignant and vice versa. So me and the team, we are still working on that. But this model is really good and it is sensitive, which is key to predicting cancer or cancer tissues. So it cannot predict wrong when an image is malignant. It predicts that it is a malignant. So sensitivity is key, and we have that. Meantime, we are still trying to improve on the model, and so that we can end up with a perfect model to reduce, of course, the death rates with the cancer patients. And we can also detect the cancer early before it gets to a stage of no return. Thank you.